Today we are going to take a look at some of the very basics of arrow diagrams, a representation that's kind of based in composition of functions. So what you'll see here is a number of different functions that can be constructed as compositions. That's what arrow diagrams are the strongest at. So we will take a look at this first one when we're looking at y equals 3x minus 5 over 2. The very first thing we always do with an arrow diagram is start with that x value. So we take the x, and then an arrow represents just a single thing that is happening to that x, and we follow the order of operations on this. So the first thing we see is a multiplication by 3. So on this arrow we write multiply by 3. The arrows will never have x's on them. They're just instructions for what to do with whatever it is that shows up on the input side of the arrow. So the arrow has a head on it. There's a definite input side and a definite output side. Now, one of the things we can do here is keep track of what we've done so far. So if the input was an x and we're multiplying by 3, then that means now that is going to output a 3x, and we see exactly that 3x showing up in what we're trying to do. The next step then is this subtraction by 5. And depending on how you're doing that, the more I do this, the more I feel like that should be represented like this, where the open parentheses represents the input at the arrow, which in this case is a 3x. So we put the 3x into the parentheses, and we end up with a 3x minus 5, which is exactly the piece that we see at the top over there. And now the last thing that we need to do is to divide by 2, and I'll use the old division symbol to do that. This means that everything that is at the beginning of the arrow should be divided by 2, so this gives us the 3x minus 5 divided by 2. And this set of arrows then that's up here that doesn't necessarily have to have all of this that's at the bottom, that set of arrows represents this first function that we have up here. All right, let's try another one. I'm going to make this a little bit smaller, set that up there so we have room to do another one. So, a little bit more complicated. We're going to do the square root of 5 minus x squared plus 4. Again, we start with the x. And the first thing that is happening to the x here, it is being squared. I'm going to represent that with empty set of parentheses and the squared, and we'll keep track of what's going on here as well. So I see the x squared matching the x squared. The next thing I need is that negative out in front of it. So I'm going to represent that with a sign change. This just says change the sign on whatever is there. And so now we have the negative x squared showing up. We get the 5 in. So our next step is to add 5. And we can restructure that, of course, and when we add 5 onto that, we get the 5 minus x squared. So we now have this piece. And then we need to stick it under the square root. So our next option there is just going to be square root, and it says take whatever is at the input of this arrow right here and stick it under the square root. So this becomes square root of 5 minus x squared. And now we have this whole piece up here. You can kind of see how this would help in noticing the order of operations. If it's being done correctly, then these things are showing up across the bottom here correctly. And finally, then we just need to add 4 onto whatever's at the beginning of the arrow, and we get a square root of 5 minus x squared with a plus 4 on the outside. Okay, so I did this example in particular to highlight this sign change part here that is fairly important in some of the other things that we're going to notice with arrow diagrams. So again, getting all of this across here, out of here, we want to make this function as generic as possible for its future uses. So we see a definite input down at this end and a final output at that end, but it breaks it into one piece at a time. All right, so let's shrink that back down, attach that to this one, and I got one more that we're going to look at, highlighting another function that we want to get in there generally. So we're looking at y equals the natural log of 5 over 3 minus e to the x. Again, we start with the x. The first thing that happens with the x is it gets stuck in the exponent of e, and this creates an e to the x. There we see the e to the x part there. We need our sign change again, like we did before. It creates a negative e to the x, and so now we have this much of it. And then we are going to add 3, which we are going to represent as, we could do it as 3 plus with this set of parentheses there. We have a little bit of freedom in how we're going to do that, so that becomes 3 plus negative e to the x. And now we have everything that is in the denominator here, but it's not in the denominator when we're right here. So to get it into the denominator, we need to invert it. That's the flip it over function. And so the flip it over function creates a 1 over 3 minus e to the x. And that gets us most of what's going on here, but we are going to then have to multiply by 5. I'm going to shift things over here a little bit to give myself a little more space. That was not what I was looking for. Okay. So creating a little bit more space over here, the next thing then we need to do is multiply by 5. That gives us the 5 over 3 minus e to the x. That's this whole part that is inside there. And then finally on that we could take the natural log of it, and we end up with the natural log of 5 over 3 minus e to the x. And if we had done anything wrong along the way, anything out of order, then we wouldn't have ended up with an exact match at the end to what we had at the beginning. And so cleaning that up one more time, and as you get better at this, as kids get better at it, they don't necessarily have to put all of these things in the bottom in the first place. Okay. But it is good at the beginning to check it. You can check to make sure that their order of operation understanding is correct. But generally this function will be represented this way, and in later videos we'll explore why that is of some use, but we just wanted some practice in getting that in there right now.